Hello, hello. We'll get going here in just a bit. Man. Say hi in the chats. Hopefully you can hear me. Hope everybody's having a good day. Hi, Sam. Hi, David. You don't hear audio coming in now. Okay. I did have to like double check my mic before I started, but I think that was okay. And I'll probably have to turn the AC back on because it's kind of warm. Hi, Fede2. How's it going? No, audio is fine. Okay, great. I need a browser. My brain is so stuck on Lego. I don't know why. Do not know why. Hi, Beata. Somewhat more quiet. That is good loudness now. Okay. Yeah, I feel like last time or during the meeting it was like too high. So yeah, I'm glad it's a little bit better. I'm gonna regret this. I'm gonna turn the AC on. It's already starting to get warmer. I'll turn it down though, which will be a little bit quieter. It's summertime. How's everybody doing? Hopefully that's not too bad. There's probably a way to like make it clip, but oh well. Okay, so let's get started. Hopefully the AC is not too loud, but it'll mean that I can actually stream for however long I want. Okay, so hello everybody. My name is Scott. I go by Tandude Online. I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out of New York City. They are, they make lots of little boards called, well, generally called development boards, like this. And under this little piece of metal here is a smaller chip that is a microcontroller. It's a little tiny computer, and it runs CircuitPython, which is a version of Python that's designed to run kind of on its own on these little microcontrollers versus like Python on your desktop. Hi, Mechatronica. Fede2 says, oh, Matter Day today. Yes. So CircuitPython is Python for microcontrollers. I'm one of the core devs. I'm usually working in C, but today we're going to be doing Python probably. And DCD says, I got my Syntheon. I don't know, you can see my, I got one too. I haven't opened it, but I got one too. So this is a deep dive. I tend to do them on Fridays at 2 p.m. here on Adafruit's channels. It's super low key, super casual. You'll see that I take lots of tangents, and I'm happy to answer questions. So Sam has some questions queued up. We'll start with those. If other folks have questions, feel free to ask. And then kind of like the preview is that I've been digging into the Matter spec, which is an IoT kind of specification for interoperability between devices. And with the ESP32C6, it became kind of more interesting. And we realized that it works over Wi-Fi, so it would apply to like all of the ESP chips. So that's kind of like the main thing I was going to talk about today. Let me answer Sam's questions first. And then I do have a little kind of mailbag sort of thing that I got, a little package I just got that I'll show off and plug. But first, let's see what Sam says. Can you talk about the current state of BLE on Espressif? What works now in 9.1? In particular, I'm curious about the pairing the 8-bit do BLE gamepads with a QT S3 as the central, then using a virtual display over web serial. I've seen notes and learn guides in GitHub about limitations on 4 megabyte ESP32 boards. Is that still a problem? So I don't think I tried pairing other devices to it. I know we did try pairing as a peripheral. So you should give that a try. Hopefully it just works. And if it doesn't, let us know. We think it's basically done. We think BLE is basically working as well as it is in NRF. But that is something I don't know if we've tested. Dan did a lot of the testing and fixing. So maybe he knows, maybe he did test that. But I'm not sure. I think it was more peripheral work that he was working on. And then the 4 megabyte thing is, so if there's 4 megabytes of flash, we have the current partition layout is such that we have 2 partitions for CircuitPython and then the user flash file system. And because 4 megabytes is pretty tight, we actually had to shrink the size of the CircuitPython image for 4 megabyte flash boards, which means it doesn't have enough room left over for all of the BLE stack stuff. So BLE is turned off on the 4 megabyte flash things. I think our plan is to, with CircuitPython 10, which I don't know when it's going to happen, what we'll do is we'll do a breaking change there where we change to a single partition rather than a dual partition. The dual partition stuff is there for over-the-air updates, but we have never implemented that. So that's kind of where we're at with BLE on Espressif. Dan did a lot of the polish work and the testing work, which I super appreciate, and Dan compliments me really well for that. DCD says, I'll try to get packet tree USB logging to work this weekend. Yeah, let me know how it goes. I was kind of surprised when they didn't, as far as I could tell, they didn't send me an email to say they'd shipped it. I just got a UPS notification that something was on the way. So I haven't dug into it. Fede2 says, I've been playing with the Home Assistant this couple weeks, and I do have some good hopes on the C6 being able to work as a Matter Wi-Fi gateway, and of course as sensors. So, yes. So Matter is different than Thread. Hams Live says, I got heavy into another project and didn't get time to check out Matter for you folks. So, I was pretty good this week getting into Matter, but for some reason last night I've been doing more Lego stuff, and my brain got super sucked into building a sorting machine for Lego, to the point I couldn't get to sleep last night, and I can't, I don't know why my brain's so stuck on it, but it is. So I'm trying my best to not get sucked into Lego stuff, and I've been working on the Matter spec. Thanks for the summary. I've got both 4 megabyte and 8 megabyte QT S3 boards on order, planning to try pairing with gamepads. We'll let you know. Yeah, please file an issue if it doesn't work. And if you wanted to, you could do your own. You could probably do your own build that had BLE on 4 megabyte. You just have to turn other stuff off, and I'm not sure how much, because the Bluetooth stack is pretty large. Then before I get into Matter, the other thing I wanted to show is I got a free sample from Analog Devices. They're working on adding TinyUSB support for some of their chips here. So they were kind enough to send me an evaluation kit for one of their devices so that I can test their stuff. And TAC was going to order it too. And hopefully they'll do CircuitPython as well for their boards. They're not super cheap boards, but I'm excited that they approached me to do it, and I was like, I'm happy to give you guidance on how to do all this stuff. So, so let me just show. Oh, it has a switch. Here's what the board looks like. And it's got high-speed USB, which is kind of neat. Maybe this isn't the... Oh no, here's the USB. So yeah, I'll be able to use that for testing. Interesting, it comes with the bumpers already installed. Gary says, how do y'all love the work you're doing, Scott? Great. Sabrina says, how much? Sorry, for this board? I don't know, I got it as a sample from Analog Devices. DB9 Dreamer says, the great thing about Lego is you can build your own prison so you can never escape. Yeah, my brain is definitely trapped. I've been trying to put together the old sets I had as a kid. So I got like this big bin of all my old Legos, and I've been trying to do that. And I had this fire truck, and I have a 2-year-old, so he wanted to build the fire truck. But I found like 2 pieces were missing, and then I realized on Rebrickable I could search for current sets that have those pieces because they're just like plates. And so I went and bought the plates right away. Do you folks have plans for the Raspberry Pi AI kit? I watched Seed Studio stream last night about it, and it looks pretty amazing. I don't think so. Not that I'm doing. This Matter work is not a small task, so it's going to be something that I'm going to work on for quite a while. I'm not sure. I think this board is like between $100 and $200. We can look it up on digikey. Go to my desktop. Oh, I didn't share my desktop. Properties, select monitor. I did that last time too, didn't I? Okay. There's my desktop. So we go to digikey. This is the Max 3260690 EV kit. $82, so not too bad. Interesting, it comes with like an Altoid tin. And I don't even know the specs of this particular chip. I think it's got BLE. They added support for more than just that one. If we go to TinyUSB, let's see the pull requests. Opened yesterday, so they have a bunch of supported boards that they added for, and they have feather form factor boards, which I think is kind of interesting. So it's 128 megahertz M4, and it's got a meg of internal SRAM, which is pretty neat. Abada says, yep, 82 is not too bad. Sometimes the dev kits are expensive. Yeah, I think maybe some of the other ones are more expensive, but yeah, this one's pretty reasonable, I think. Especially for a mega SRAM. Mega SRAM is not anything to sneeze at. So yeah, Analog folks are working on that, which is awesome. So they're adding TinyUSB support, and then hopefully on top of that, they'll be able to build debug adapters in the mints tin. Hey, Victor's watching. Victor works for Analog, and is one of the folks that hooked me up. I haven't opened that part. I went straight for the EVK part. Just was delivered. Oh yeah, slippery slope. Yeah, the Lego thing is a huge slippery slope. My brain, I don't know why my brain is so stuck on this. Like, I literally could not sleep last night. It's unreasonable. Anyway, so today, the work that I'm supposed to be doing is Matter. And so I just pushed this CircuitMatter repo with the beginnings of my work. So let me take a step back and kind of try to get an idea of what Matter is. So Matter is a new standard for like home automation IoT devices. And where you may have seen it is, for example, this light strip here is Matter connected. And Matter devices that are certified will come with these QR codes and the logo and a setup code. So what you can do is you can take your phone app, you can scan the code, and it will like commission the device onto your network, and it will interoperate with like Apple Home. So like you can add it to Apple Home, and you can set the light to be different colors. In fact, I wonder if I could do that live. So if I pull up Home and I switch to the Office, so if you see the lights behind me, I can turn them off from my phone and turn them on. This is the UI here. And then you can also long press it. See, which way do I go so you can see the lights? So I should be able to dim it, and then I can make it blue, and I can do that. So that's all through like my Apple Home app. You can even select the color, green, red, purple. So this is connected over Matter. I don't actually know if it's thread or not, but it's a new standard. Yeah, Abadus says it was such a pain to have so many protocols in the IoT wilderness. Yeah, well, let me tell you, this is not a simple protocol, but I have been like pleasantly surprised with how well it works. And so let's pull up the spec. And I think there's a reasonable overview here. So the spec is freely available. You do have to you have to like request a copy, but then they'll send it to you like automatically. And so here's kind of a basic idea. So application layer is what I think of as Matter. So that's the like protocol for discovering devices and then talking between devices. That's all this application layer thing that I think the lower diagram will show you. But the thing that I wanted to point out is that it kind of unifies on top of IPv6. So IPv6 is some like networking, low-level networking protocol where you send and receive packets on ports. Now, the IPv6 can then be done over Thread, which is kind of like Zigbee. It's a mesh networking protocol that's low power. And the C6 and the H2 have Thread support. But you can also do it over Wi-Fi. So, and that's super simple to just do it over Wi-Fi. So I'm actually targeting, I'm narrowing down my scope to try to just do Wi-Fi based Matter at the start. Hamzab says, I have a light behind me that I told Apple Home to turn on at sunset so I can keep track of the exact time of it as the days get shorter. It does go down to the second of the sunset. Oh, interesting. Yeah, so both Apple Home and Google Home have like built-in Matter support now. And they're part of this like giant consortium that designed this little bit of a monster of a spec. But I have yet to find any big chunks that I'm like, oh, I wish you didn't do that. It's just like kind of complicated. So because it's built on IPv6, I was like, oh, you know what? Like, why don't I just implement it in Python? Because I did build, Espressif has an esp-idf library. So Espressif has this esp-idf library, and it's got examples where you can like make just an RGB light. And I had a tough time getting it working. I did manage to get it working, but I had a tough time doing it. There's a lot of dependencies. So this this here actually wraps. So here's some expressive components, but then there's also project chip. This is the old name for it. So this is an open implementation of Matter that kind of all the C-based things are built upon. But getting it to build was kind of a huge pain. I did get it working, but I didn't really want to use this to integrate into CircuitPython because I would have to kind of carry all of that C++ code with me. Whereas if I did it in Python instead, I could then load it as I need it, but also do it portably. So I kind of was like, oh, it's just based on like UDP packets. Like, I wonder if I could just re-implement it. And I pitched it to Lamore, Lady Ada, and she was like, okay, that sounds like a good plan. I was like, so I've signed up to do like a minimum viable Python-only Matters implementation. One thing that gives me a little bit of hope that I haven't gotten myself in too deep is if you look under here, there's a matter.js, which is a complete TypeScript implementation of the Matter protocol. So somebody's done the same thing for JavaScript already. And in fact, there's also a Rust version as well. So why not make a third or fourth implementation that's Python only? And I should say that I'm not targeting to be a certified device. If your device is not certified, Apple will prompt it and say, hey, this device is not certified. Are you sure you want to add it? And then there's an add anyway button. And then it works just fine. So I'm like trying to get, I'm trying to go down this like hobbyist happy path instead of the like certified and validated and all that stuff. Henslab says, I also had issues getting the SDK to clone properly on my Mac. If you couldn't get it to work, I had no chance. Yeah, I could get it to work, but it wasn't great. If the Matter project came to us and said that like we want to use your code, like it's liberally licensed, they could totally do that. DCD asks, 1024 pages is a large spec. What stages do you go through to understand large specs like that? So I started by reading it, not the whole thing, but particularly like the introduction and the architecture. And then if it gets too much in the weeds, I'll just read like the first paragraph and then skip to the next section. So basically trying to get like an idea, and you'll see here I have the table of contents open. So like all these cryptographic primitive stuff I kind of skipped over because I'm to the point where I understand it at the high level. Carestring88 says, this device is not certified, but does it matter? Not really. It doesn't really matter, but again, we wouldn't really want to use that name either. So I was like skipping around a little bit, trying to get an idea for it. And the secure channel chapter is really helpful because it's yeah, so I kind of skimmed and read a lot of the beginning chapters, but now I'm in the point where I'm implementing it, and I literally just wanted to start from the start. So how do I set up my computer? I'm prototyping this on my computer. How do I set up my computer so that in Apple Home, when I say add accessory, it finds my computer? That was the first part, and that's under secure channel discovery. So it uses MDNS, which is, if you've ever used CircuitPython.local, it's the similar thing. It's a way to discover other devices on the network. It's super common that like Apple devices use it for HomeKits and AirPlay and all that sort of stuff. Maybe uncertified should be referenced to as antimatter. I totally like thought about naming it antimatter, and there's already like a PyPI package for it. So I think Dan or I suggested CircuitMatter to go with CircuitPython, which I kind of feel like I'm going to regret because like CircuitPython is in my fingers and CircuitMatter is not in there yet. But PyMatter was a little questionable. Like there's a GitHub repo called PyMatter for the Mattermost chat stuff. So we kind of didn't want to go MatterPy or PyMatter. So we decided on CircuitMatter to start. So I basically started from the top. I had one Python script. I set up MDNS using Avahi to publish a service. So basically following this commissional node discovery thing. So I'm assuming that the device is already on the Wi-Fi network. And then once it's on the network, how do I get hooked into Matter? So you use MDNS to do that discovery. And once you broadcast that, you type in a code, and then it will send a UDP packet into your port that you specified in your MDNS response. So the next step is what is that first packet and how do you parse it? And then the step after that is how do you respond to it? And that's kind of the phase I'm at. The higher level thing is that this secure channel thing is that there's a very brief period where there's a brief period where you're not encrypted at the start. And so it's literally like the first packet is initializing the password-based process for securing a connection. And then once you're encrypted, then there's a like further protocol for how do you like tell the light to turn on, or a whole lot of other higher level stuff that I haven't gotten to yet. So I'm gonna have to look at these cryptographic primitives soon, but I'm right now in this message frame format I did first. So the first byte in the UDP packet is this message flags, then session ID, security flags, blah, blah, blah. And then once you get into protocol header, now you're doing some other, so there's message header format, and then the payload is encrypted. And then inside, right now it's unsecure, so you don't actually have to decrypt it. But then there's a protocol header, and then after the protocol header is an application payload, which is this thing that's encoded in a TLV syntax, which is a tag length value encoding. This kind of shows it. So passcode authenticated session establishment. The first thing you get is a PBKDF parameter request, and that is what the first packet that I've got and I'm trying to parse is. Whew. So there's a back and forth to establish a secure connection based on a password, and then once you have that, then there's more protocol that happens after that. It's a lot of read the spec and implement it sorts of things. And it tells you, okay, the parameter request is a structure of this form. Any questions, or have I put everybody to sleep? I have a family friend that's like, yeah, I watch your stuff and then it puts me to sleep. And I'm like, well, I'm glad it's useful. So my general approach is learn things in the datasheet as I need them and start from the beginning. So how do I get discovered on the network? And once I am getting UDP packets at, what do I do with them? So Fede2 asks, what hardware for today are you using in the H2 dev kit? So I'm actually using my laptop or my desktop. I'm using regular CPython to work on this, which is the other benefit of being Python level. I'm just writing it in Python on my desktop, and my desktop can do IPv6. And then I should be able to, so Jeff is helping me out on this. So Jeff is, I kind of asked Jeff to look at IPv6 support in CircuitPython so that when I switch over, I can just switch my socket implementation, and then I'll be able to do UDP again. And that's true for Thread as well. So the hope is that with OpenThread or with Thread, there will be just a like, turn up this network, like log me into this network, and now I just do IPv6, and all of the stuff that I'm working on now just applies. DCD says, I just started looking for the Matter spec, just got to Wikipedia, not Z here. I always love these deep dives. Ah, thank you, Fede2. Okay, so if you want to find the spec, you go to buildwithmatter. Look at all my Lego completions. I'm a little bit down that rabbit hole. You can click download Matter specification. You check the ones that you want. I just checked these 4 1.3 ones. And then you click download, but I think it's gonna, yeah, it has you give them your information and submit it. And then they just email you a link to download it. So if you want to follow along, that's how you can get it. It's fine. Randall says Z. I'm glad I put you to sleep too. DB9 Dreamer says, sounds hard to debug until you have a lot of layers in place, I guess. Yeah, so basically the point I'm at where I'm just trying to parse that first packet. I've actually just copied it into my Python file and I'm doing all the parsing. So there's this format called TLV, tag length value encoded stuff. That's what kind of like, this is saying like, hey, this is the TLV schema for the packet that you're going to get in. So I have a sample packet, and I just want to parse it. And then in the appendix, there is an explanation of how tag length value encoding works, which is kind of crazy, but I think I've got most of it. And then there's schema, so like what does that schema mean? In some places they use the schema, and some places they don't, which is silly. Like other parts of the spec where it's defining a TLV struct, they don't use this syntax, which is kind of weird. And then they also tell you like, hey, if you're gonna print it out, here's how it should print out. Which is what I've done some of this as well. So I'm parsing packets at this point, and then I'm going to be able to put more logic on top of that once the packets are parsed. How am I doing that? And if you have questions, I lose you, please ask. I thought this would actually be a good chance to talk about a feature of Python that is definitely not very well known, but one that I love. And I don't know if I've talked about it. I don't think so, but I think it's complicated enough that I should talk about it again. And it's called descriptors. I was talking about this to Dan last time. TLV schema packet parsing arrays in CircuitPython. Yes, so descriptors. Descriptor guide. So this is a thing. Oh, I switched to a tab that's in my other browser. So a descriptor is a feature of Python that lets objects customize attribute lookup, storage, and deletion. If you've used the CircuitPython register library, you've used descriptors before. They are weird, but they're super powerful. If you've used properties before, you've actually used descriptors as well, but it's hidden from you. So let's start. Avidus says, I was just reading about descriptors. They look useful. I think they're super useful. Let me start with what a property is. And let me just, property. Descriptor guide. It's in the descriptor. Don't use Python properties. I disagree with that. So let me just have a scratch file here. So if you, what you can do is you could say, okay, class foo, and I want to, you could just say pass and then do new foo equals foo. Weird but super useful. That should be on a sign at Adafruit or an unofficial motto. It's totally true. You know the WCH stuff that Lamore is interested in? She said, this is weird. Let's like work on that some more. Like weird is definitely an enticing thing for her, which I think is really cool. Actually, you know, I'll just, I'll save this as a descriptor example. So we can get some highlighting. So what you could do is you could just say new foo, and sorry for using foobar. But so let's build this up. So here is a super basic example where I'm creating a class. I'm not even assigning an it has nothing in it. That's what pass is doing. But then I set the .bar value on it to hello, and I then print it out. Now, what I could also do, the next kind of iteration on this is what it's completing for me, which is kind of cool. And I think I'll do it like this, though. Let's call this foo2. I do like GitHub Copilot is quite good. So, okay, so now we're getting hello. Let's be a little more specific. Hello 1, hello 2. So here's 2 examples. I'm basically doing the same thing, but in a little different way. One is an object is getting some random thing added to it. Next, the second thing is, and maybe test docstring. Can I do, will it print out the docstring if I do print help foo2? What does that do? Data descriptors. How do I do help without a pager? I just want to help. I want to invoke the help system. It doesn't work quite as well as I was hoping. The def needs to start with the docstring. No, I think it goes below, but we could see. Because it's not a docstring for. I'm trying to document test doc bar. I don't know how smart the help system is. Right. See. Now it's put it on the method, not on the attribute. What happens if I put it? What is this? help string is an attribute on the class. Well, I was hoping it was going to like tell me all of the... It says data and other attributes defined here, but it doesn't include the text for it. And if I put it above, it's not going to be right. I think it is below. The problem, the help thing is just not doing enough work for me. Haha. CareString says, oh, you want to document the attribute, then make it a property. Is it the doc? Can I do? Well, I don't want just the doc. I want like, you know, what read the docs would give you. I don't know if there's a programmatic way to do that. Can I do help? New foo2? What does that do? It shows bar again, but it doesn't give me the description of it. It's not that important. It's not that important. Okay, so I think the right way to do this would be to do it like this. It's weird, but I think that is the format. So that's how you can document attributes on the object. But what if you want to do something more complicated? For example, you may want to do an I2C transaction if you're writing a driver. So let's do foo3. And what you can do is you can do, let's just set it to none. I guess we can have the, no. We no longer want that. Property. So this is one thing, and then you can do @bar_setter def bar value. And now we can do new foo3. It makes me giddy when it works like that. Like, it's not perfect, but like, it's pretty good. Maximum recursion depth. Okay, so the reason that is that we're kind of storing it internally as the same name. So if we want to hide the value internally, we can do that. Hello, 1, 2, 3. But what we'll find is we can, oh, that's my indentation's all off because Copilot's not being smart enough. We can put things in here like read bar, print write bar. And now when we run, we'll see that it actually writes bar, reads it, and then prints. So this allows you to, from the outside, it still looks like you're doing the same thing, but internally, you are doing some more work. In our example, as CareString was talking about, if you want to document this attribute now, what you could do is the bar attribute is a fine example. And we covered this actually in the dev guide for CircuitPython as well. If you put a doc string in the setter, it doesn't actually matter. So that's all well and good. But what if we wanted to make this more generic? So imagine we want to add Baz. Sorry for the terrible names. And I don't want this. But I want to do the same thing at property. Oh, whoa. I have a multi-cursor going on. And I want a Baz setter. Clever. So now I'm going to do the same thing foo4. I'm doing Control D to select all the threes and type 4. And I'm going to do, sure, hello 5. Okay, so what do we get now? We get our read bar, write bar, read bar, hello 4, and hello 5, but our Baz stuff doesn't have it. But let's say we do want it. Print read Baz and print write Baz. So now we've got very similar implementations for two different properties. And this is, to me, where descriptors come in. It turns out property actually is constructing a descriptor under the hood. And it's the main use of descriptors, I think. But let's do a foo5. Let's say class foo5. And we're going to do bar equals logging descriptor. And we're going to do Baz equals logging descriptor. And I'm going to copy these. And I will change these to 5. 5 bar, 5 Baz. And I'm going to save it, and it's going to complain at me, but we'll see what it does. So it says, oh, logging descriptor doesn't exist. And it did it when it hit the class definition. Kerosene says, I warn people to be responsible with the amount of side effects they do. It can become very hard to reason about because as a user of the class, you just expect it to follow assignment and value semantics. Yes. Right, and I like to use it. So it looks like an attribute from the outside, so you want to make sure that you like abide by that contract. That's charstring 88's point. But I've been okay with it, and we've had debates about this, of whether like doing the assign and reads, or the reads and writes under the hood over I2C is like too far out of expectation. Okay, so what we want is we want a new class called logging descriptor, and we are going to let's call it read and write again. It's getting a little ahead of the game. Let's just call it read write for now. Instance owner, that's not right. What I call this is option value. Instance isn't a bad name either. So what we're going to do is we don't have a little bit more information. Actually, what we'll do is we'll say we're going to store this in slot 1 and slot 2. And we'll say this is slot. And I'm getting weird. But I want to be able to say object dot slots self dot slot and dot slots. Okay, it's getting tricky now, isn't it? This is a good detour though, like understanding that like descriptors are super powerful, but they're very weird. Yeah, slots is something different. That's not quite what would be a better name for it? It's just something temporary for now. There's one more concept that I'm trying to avoid. So let's just do that for now. And let's see what, I don't even know if that'll work. Foo5 object has no attribute slots because we are, oh, we didn't set it. So what we could do is we could just say definite slots. Sure. You could like auto detect whether it has it or not. Write read, and we could put the slot in here. Or we could call it tag. Let's call it tag instead, because that'll match better up with what I'm. All right, questions? Am I officially losing people? So now we can see we're like writing and reading tags. So what we've done is we've taken this duplicated code between the properties and we've factored it out into a separate descriptor class that has these getters and setters, and they're kind of weird. Yeah, the canonical thing you want for descriptors is this page, the descriptor guide. It's like what I always go back to for referencing it. But yeah, so the way that I think about it is that it's factoring out, it's factoring it out. Now, let's do one more iteration. Well, let's do another iteration. I don't know how many I'm going to have here. So let's do a logging descriptor 2, but let's not take tag. And this is something I think that doesn't work in CircuitPython. Name, none. But then there's a def set name, I think is what it is. Owner name, okay. So private name. So yeah, this is exactly what I'm doing. Self name equals that, and we'll do exactly what they're doing. And now we can say self name, and we can read the object. Right off of it. And we'll give it a default value. And then to here. Nope. Hi, unexpected maker. Okay, so that's foo5. We want this to be 6. So now we can see that we're getting read and writes for that. I just saw on the Adafruit website that Adafruit is moving. How did that come about? Have I been living under a rock? I don't actually know how public they've been about it. Let's see what they say. We are moving. Orders will take extra 7 to 10 business days to ship. Let's see what they say. That's right, folks. We're heading to Brooklyn. That's pretty vague. But yes, the Adafruit factory is moving out of Manhattan to Brooklyn at Industry City. I think they moved receiving they move like the receiving department first, which I thought made sense. Like you start shipping packages to the new place first. They have a whole like detailed thing. Yeah, totally vague. I think part of it was just like their Manhattan lease was up. I think that's okay to say. But yeah, so that's why things will be different in July. It's because they are really busy. Busy moving Adafruit. Okay, so that's this set name thing. Set name does not exist in CircuitPython, I don't believe. So the form that I'm using right now is actually this tag thing. The other thing I want to just show with let's just do one last one. And I said that last time, but I want to show this thing where I want to say self.count. And then I want to count accesses. So I want to do self-count plus equals 1. And then I'm going to put it here. So let's see, just one more thing. Foo7. And what I should be doing is I should be doing an extra print between these. Yeah, mostly on 1.4, more space, better rail, subway access. Yeah, I haven't had the time to watch Ask an Engineer. They have a moving company that's doing the moving. But I would hope they're taking videos. I don't know. They did not want people to visit because they're busy. Okay, so this looks pretty expected. 0 to 1 for bar and 0 to 1 for Baz. But I want to show you a caveat, a gotcha. So I'm going to make a new foo7b. So I'm going to make another foo object. And I'm going to do the same thing. And I'm going to print it out. Could work with that grid structure in New York. Okay, so this is the thing that I want to highlight about how just using descriptors like this is weird. So they counted 2 and 3. It's only, so the way that Python classes are created is that you actually run the contents of a class as like a function, like you execute it. So let's actually just, we'll also print create descriptor. And what we can see, so that's actually kind of interesting. So let's put a print here. It's interesting because it happens before the print. So this is proving my point that it actually, this init of the descriptor is running at class construction time, not when we're instantiating the class. So that's one of the huge gotchas with the descriptors, but it's also super powerful because it means that you only have one instance of a descriptor for all instances of the class that it's in. Does that make sense? So it is convenient for like that state gets shared. An example of where this gets tricky is like in the register classes, there's a buffer, and that buffer is actually shared across instances of the thing that it's on. So any questions about descriptors? I think I've kind of exhausted it, at least in terms of examples. And you know what I'm going to do? I'm going to just dump this into a gist. For example, why? I'll rewatch this later. Yeah. Hopefully it's helpful. I prefer using the term initialize, but I hear instantiate used too. Is there really a difference, or is it semantics? I think instantiate makes a slightly more sense in that what you end up with is an instance, right? So when you instantiate something, you're given an instance. So you're like creating an instance of a class. So how does this fit into Matter? So we were talking about parsing packets, and I really like, so from the outside, all of these different implementations, it still just looked like it was attributes under the hood, which I like. So it's a structure, there's just values in it, just give me attributes from the Python perspective. Now that gets a little trickier when you want to do parsing. But so I was talking about this password param request. So what I'm doing is, this is what the encoding is in the spec. So it's got 4 fields and an optional 5th field that's also a struct. And now, and if you've done CircuitPython before and you dug into the register library or the BLE library, they use these descriptor tricks too. Yeah, and init is the name that, like, that's the actual term for the function too. You're like initializing the instance, I guess. I don't know. So what I really like to do is use descriptors in cases where I'm doing something that's like a structure, very declarative. So what I've got here is the name, and then I say, oh, this is an octet string member. So that's like straight from here. And then the tag. So in the encoding, there's a number that tells you what field it is. And then there's also constraints about length. So that's what this is. And then session ID is a number. It's tag 2. And this is like how to unpack it using struct unpacked, which Jim made a comment. I was talking to him about this, and it's like, oh, it really sucks that struct always returns a tuple, because that's actually an allocation. So because you're factoring out all this parsing code, there is a world where we could add like a new module that works just like struct, but if you give it one field, it just returns that thing, which would be handy. Carestring points out this bites you in the same way as mutable default parameters of functions. Yeah, that's tricky. That is tricky. I don't know if people know this thing as well. So let's take a detour and talk about what carestring is talking about. So let's say we add a def append, and we're going to give it a value, and we're going to say like L for list. So say, okay, if you, yeah. So we can say L equals append 1, print L, and L equals append 2, print L. If we save that and run, we get 1 and then 1, 2, when what you might think you're going to get is 1 and 2. Let me just print next to it. Like, that's kind of what you would normally expect, like logically expect. That's a char strings point. Is that, yeah, it's the same objects. All right, so it's 3 o'clock. My brain is so hung up on Lego sorting. My brain's like, oh, let's think about Lego sorting. I don't know why. I don't know how it got so wedged in there. Or how I'm going to get it out. Okay, so I've got, I'm declaring the structures that I want to parse. And under the hood, I've got a TLV structure. So that's what the outer class inherits from. And then I have some, like, a top level member that stores whether it's a tag and it's optional, and then a setter. And I actually want to factor out the getter as well. I'm guessing your friend got to sleep a while ago. Yeah, probably. All this descriptor talk. Okay, so I do want to factor out the getter because the getter's getting, I'm adding this notion of cache value. So the way that I implemented it is I was trying to make it so that it wouldn't parse the packet until it needed data from the packet. And I was thinking I would make it so that it only parsed it after you needed it, or it always just backed it by the memory buffer. But that gets really tricky when you start writing it to it, because the way the TLV encoding does it is like it can a single value's entry can vary in length depending on the state of the value. Like strings, even though the struct says that it's a 16-bit number, if that number is less than 8 bits, like if the top 8 bits are 0, the encoder has the option of encoding it in 1 byte, not 2. So backing straight to the memory buffer would potentially mean that you have to move a lot of stuff around. So what I'm working on is adding this cache value thing. And what I've also done is I've actually written some tests. Well, I've started writing tests because in this, there's examples. So Boolean false is 8, Boolean true is 9, and that's if the tag is 0. They have more complicated examples, but I was like they give all these examples, and I'm writing this code that's gonna it's kind of foundational to all of the higher level stuff. Maybe because they have examples, I should actually just write some unit tests to actually verify that this primitive code, this low level code actually works. So that's what I'm doing, and I'm trying to do encoding as well at the same time. So I have decoding. So given the incoming packet, print it out. And can I actually run that? CircuitMatter. I should actually test this. Attempted relative import. Maybe I have to do it like Python-m. I haven't actually done this since. Module name, CircuitMatter. No module named main. CircuitMatter is a package and cannot be directly executed. Interesting. I've done some reorganization on this, so let me just see if I can't. Duplicate. I can add a main. And in my main, I'm going to delete all that stuff. You can see like I have commented out code for like open a socket, set like Avahi publish service. Not too bad if I do import. I guess I could just say import CircuitMatter as CM. Does that make sense? I don't know. That's not going to work, but let's run it and see what it hangs up on. I reach for hypothesis tests when I implement specs. Yeah, I think most people are asleep. The chat's real quiet. Name security flags is not defined. Did you mean security flags? Okay, so this is I could just say from security flags. Does that get me past it? Yes. What do you think? Should I import explicitly, or should I just import it as something? Maybe that should be a constant, or an enum too. I don't know, maybe I just want change my mind. I don't know, what do people think? Multi-cursor. That was all generated by so this is where it's sending me down. None type object is not subscriptable. Okay, so we made it quite a ways. We are in line 38 of get. We are trying to get the parameters off of a response. I don't know anything about Matter yet, so no idea if what you're doing is good, bad, right, wrong. Well, I'm just talking about Python style. Like, do I implement each thing that I'm using explicitly, or do I just import the whole module and as a CM thing? We're not getting too much into the structure yet. But I know this stuff is something that I'm going to need. TLV line 38 is scan until, and we are, I think actually what we want is we just say, is none. Just do that. So now we're in tune 18. Yeah, so this is a little weird. Struct member is going to be a little weird because we say do we want to automatically initialize it, or like, do we want to return an empty version? Probably. Return an empty version, or have you assigned to it? Maybe that's what you should do, is you should directly create it. Yeah, I think that's right. I think that's the way I should do it. So in main, what I want to do instead is I want to say, is that right? Is that what I called it? No. Da 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 da. All right, we got further. Now we're in print. .196. What's line 196? Okay, so I want to you can never win, so do what you prefer. I want to factor out the getter. And then what I'm going to do is I'm going to have, I'm going to factor out the getter and then using this one, and then I'm going to add a decode and encode instead. So this is going to be value equals self decode, buffer, and offset. So now this becomes decode self buffer offset equals 0. Return. And now we do this decode. Da 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 da. Da 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 da. I need to do buffer and then I do like how it's cleaning it up. And you know, I guess we can't decode it without context. Tag value length. I guess maybe we do need objects. Or I could say buffer length offset. Okay. And so we'll need to add length here. And decode obj tag value. So now to decode it. Hey, that's pretty much there. So buffer length. I'm adding the offset equals 0 so that I can call decode directly in my tests. I guess it's not optional. And we don't need to do the to do because we're going to do that. Does that make sense? Maybe we should wrap print as well. The value is null thing, so we could do where we use it. Let's see if it works. Key error. 138. We're in print. We're in get. I think the thing is that our get needs to it's not handling. I'm just going to return none. We could have like a validate later. Not thinking about Lego music. Oh, you said the word! If I fall asleep, it's because it's after midnight. Well, maybe I would have gotten to sleep better if I turned on my own deep dive last night. Although not this one, because I keep mentioning the L word. Okay, so it's working now. Responder session params is null. So I am able to print it out. I can print out the other one too. I don't know why my... So now it should be easy to add more TLV structures. Math, there we go. I suppose we need math. So can you walk through the data structures input and how it gets printed to the output? Yeah, so we can talk about how printing it works. So here's the requests that we're printing out. So how does printing it work? So the objects I'm creating inherit from this TLV structure. So when you print it, print automatically or implicitly converts the object to a string. And in Python, that's done through dunder string. And so we do some tricks here. So we say members is going to be the printed version of all of the fields, because at the end we're going to join them with commas and indentation. And then what we do is we introspect, and maybe we should use inspect, but using vars, which is a way to get the attributes of on a type. And it doesn't call the getter on the descriptor, which is actually kind of hard to do. So you can use vars to get the names of all of the attributes on the class, or it's a dictionary of the attributes, and then you can get the class object. So it's the instance of the descriptor. And now we say, oh, if it starts with an underscore or it's not a member, an instance of some sort of member, then we skip it. So we continue. Otherwise, we print field, which explains why we're getting a lot of debugging information. Yeah, there's a lot of print still. We can remove that. So then on the class, we say, hey, print out this particular, for this object, print yourself. If it's an instance of a struct member, then we actually replace the new lines with new lines and indentation, so that indents or indents substructs. We join it all together and we return the string, and that's what gets printed out. Tyus says, late to the party, is the TLV backup type thing a matter specific thing? Oh, and what device are you interrogating connecting to a light bulb? So I think TLV probably has its history in Zigbee. I've not actually looked. It's kind of a family of encodings, but this encoding is matter specific. I think it is matter specific. I haven't actually looked. I briefly looked for libraries to do TLV encoding, but they probably don't work how I want anyway. And then the question is, what device are you interrogating / connecting to? A light bulb. So this original packet is the first packet that I get from my HomePod Mini to onboard a device, or onboard's not the term. The term is commission. To commission a Matter device to the HomePod Mini. So I'm in the future going to want to in the future, I'm going to want to act like a device. And so, yeah, I'm parsing. Carestring says, do we just need to parse or do we need to construct these as well? We do need to construct them. I have not done that. That's kind of like the next thing. Is I actually want to add an encode to function, so, or encode into function, so that you can give it a byte array and it will give you that. So yeah, we do need to construct them because we get this parameter request thing in and we need to then respond with another TLV encoded struct. So that's where I'm going, but maybe not today. I think today's maybe better spent. So it runs just fine. And now we can run PyTest. So maybe what we should do is we should actually, well, there's some encoding stuff. But maybe we should just finish doing the unit tests for decoding. Earlier you mentioned unit tests. Is this pre-work for unit tests? Yes. Well, getting that working. So let's just comment that out. And just do decode for now. So all our tests should pass. Yay. And in fact, what we can do it as instead is we could just say, I mean, I kind of like printing it out, but we could also assert no, let's just do it that way. That's fine. It's a little weird that it's like that, but. And maybe let's not. So this is grouping tests. So let's just do true. False. Two passed. Okay, so you're right, Carestring, that we need to do encoding or constructing these, but I don't think I'm going to do that right now. I think I'm going to wait until next week for that. It might change my unit test structure a little bit, because I'm going to end up duplicating that. So maybe I just do it right now, because I'm going to do it for all these things, and I don't do a lot of unit testing. So I don't know what the right way to model this is. Maybe Carestring, you actually have a suggestion for how to structure this. Like, how do I structure a test that's like the reverse of this? I wonder how I should do that, actually. It's perfect for hypothesis. If we decode and encode, it's perfect for hypothesis. Could you give me an example? Or should I commit it and you can change it? Like, I'm totally game for it. I just, like, I don't know. I don't know enough about it. So I'm open to suggestions. I don't want to, encoding is going to take too much time. let's just do this. Given any bool, assert b equals decode encode b. But I also want to be able to say, like, this is what the bytes actually are. Because I do want to check what the bytes are too. Look at that. I love Copilot. Like, it's so growing on me. So a trick, I think, and I think Lamore was suggesting this to me, is to actually have stuff in comments, because it uses it as context. So, like, that's how it knew how to change these things. So let's just see if it works. Maybe. Yeah, so now 4 tests pass. So isn't that... I love it. Although, I think... But I want to do... Should be able to do that, all these. Signed in to octet. For octet. It just astounds me. This is, I'll tell you, this is something, a reason that I was like, yeah, I can write tests, is because I had a feeling that it would be ripe for auto generation. Like, Copilot's just writing it for me, which maybe goes to the point that I should programmatically do it, but it seems right. I don't know, how do people feel about this? Unsigned int. Like, it's astounding. It's putting all this encode stuff that I should probably just remove, but I don't have UTF-8 support either. Maybe we should just do that. I can't deny having it predict my refactors based on later context was good today. 200 lines of worth of repetition, 20 variations, only 1 of 19 incorrectly assumed guesstimated. One octet length. How many is this? I think I want, let's just say it's 16. Max length. Class test. Almost. So close. Oh, so that's not how it's supposed to print out. I think it's supposed to have. It's not going to work because this doesn't exist yet. But. And we don't want a byte string back. We want a string string. Oh. Yes, I know it doesn't exist. So you are getting into test-driven development. It's not. Okay, Mark says, writing unit tests and other busy type work is a perfect use for AI. Fede2 says, love Copilot. I've been using it only a couple of things, and I normally develop inside risk-free log. I'm too lazy to set up to use SSH on this. Okay, Copilot is a time saver. I think the reason that I was willing to do this is, one, I thought Copilot would be as good as it is being about writing it for me. And two, I already had the source examples from the spec. So it's like, if I already have these examples, I really should just like at least make sure those cases work. So yeah, it's just like, and it's such a low level thing, like this encoding and decoding, that it's like I really should make sure my foundation I'm building on is reasonable. You know, I do hope that like this thing, like we actually use it and it works and all that stuff. So okay, so we're gonna do let's just do another. Should be simple. And I guess we haven't done encode yet. And then for printing, I think printing we want to tweak a little bit. For printing, we just return, well, no, we have to quote it. That's right. Where can I find the repo? Maybe tomorrow morning I can add those hypothesis tests. So I just pushed it. These tests are not in there yet. It is, let's just do it right now. Tests are passing. Git status, git add, CircuitMatter, main. I need a better git ignore file. Copy raw file. Oh, darn it. I must have committed those PyCache files. Should have set it up immediately. The repo is github.com/adafruit/CircuitMatter. This parsed hex VM is I was using IM hex to annotate bytes. Thank you. github.com/adafruit/CircuitMatter. More tests. And UTF-8 string. Push to main. So now it's right here. And it's public. I just pushed it like right before the stream because I was like, before I tell people the name I'm thinking it should be, I should probably actually grab them. So I did. All right, let's see if floats work. I don't actually know. I don't know if they will. I think they can use the number one. Let's just see. Oh, first we have to do the octet string. Oh, and a null test too. Class. Ta-da. Good guess. Number none. Does the license on the spec allow you to add it to the repo? I don't know. Oh, I assume I can't add the spec itself to the repo. I thought you were meaning the examples. I was like, I'm pretty sure the examples are fine. Rule member. Optional. True? That's all right. Oh, that is where I want it. Ah! Class. Single provision float, but I want number. Number with a little f, maybe? Well, I'll see what Python says about that. Holy moly, that's why it was slow. Does it work? The spec documents themselves, I assume because they're like gated based on your information that you shouldn't just send them. I think we could finish these and then see. Oh, it's optional with caps. It's a good example of like Copilot almost getting it right. Okay. Okay, so negative infinity didn't work. Null the code failed. Let's actually look at what the right formatting character for floats is. F is for float, D is for double. Which I assume means what I think it means. Like the size was right. Like these are completely different. Single precision floating point should be 0, 0. Let's just do one at a time. Okay, so we're expecting 0.0. Let's actually see what the spec says in terms of how to format it. TLV payload text representation, primitive types, signed integer, unsigned integer, should have a U after it. Floats! It doesn't specify. It doesn't specify how to render a float. So because of that, I'm just going to change this to do 0. And then our test unsigned has the U after it. Okay, so that was, it got it right. And we're trying to make an optional bool, which is weird. So the optional bool is failing. Any final questions? Get them in, please. Is there an MDNS to it? Big Indian? Rai says, I just started playing with Matter over Thread using the Scilab's Arduino core and a SparkFun thing plus Matter. I might look into adding Thread as a network interface to the thing plus Matter CircuitPython port. That would be awesome. I actually don't think it's going to be too hard. All of this stuff is the hard part. I looked briefly at like the esp-idf thread support. Well, I guess you're talking about the Scilab's stuff. So the Scilab's port was done by the Scilab's people. So I don't know what's involved there. This is keeping me awake. I don't get what those friends of yours means. I'm off to Bob Ross to calm down. Have fun. Thanks, CareString. Could you test the float encoding in C? I could. I mean, maybe float encoding is not floating? No, maybe it's not single? F, D, and E conversion codes. The packed representation uses the IEEE binary 32, binary 64, or binary 16 format, regardless of the floating point format used by the platform. F, D, and E. E is like half size. IEEE 754. Floating point numbers. IEEE 754 2019. Encoded in little endian format. Specifically, the reverse of the order described in external data representation. So that's I probably need to reverse my bytes. Can I do that? I tried to do that, didn't I? Is that changing my number at all? No. What does this say? It doesn't seem like it's swapping them. I could just try to reverse it and see. I also have a C6 and H2 might start there due to the popularity of ESPs. I want to use the web workflow over thread for some robotic stuff too. I suppose you can do IPv6 TCP over thread, right? Is what you're thinking? Are there any Matter or other integrations that you've been fantasizing about for a while, briefly motivated by the idea of? I mean, my goal is to just do the basics. So like RGB light and temperature sensor, and there's a good list, like Apple Home Matter support tells you like what devices it supports. Maybe not there. I forget. somewhere here, it does tell you what device types are supported. Not going to do OTA either. You can't do OTA for non-certified devices. Somewhere here it is. I found it at one point. Like, just a list of, maybe it's on this page. Somewhere here they tell you, oh, here we go. Currently supports these types of Matter accessories: air conditioners, bridges, lights, locks, outlets, switches, thermostats, blinds and shades, and sensors, motion, ambient light, contact, temperature, and humidity. So there's a list of, like, I'm not going to do bridges, I'm not going to do air conditioner, but lights I'll do, maybe locks, but, like, it should be pretty straightforward to add, like, generic device support once you have all of these primitives. There's a lot of primitives to build, but, like, once you're building on top of that, then it should be okay. So Rye, there is work in, Jeff is working on better IPv6 support generally in CircuitPython, so be aware of that as well. Why isn't this working? I don't know. I'm not going to do it. My brain's done. Is that right? One 1.0 over 3.0. And what should it print out as? Am I watching the clog and ready for like? Bridges, I think, is bridges is like devices that interoperate with other networks. So you can have like a Zigbee bridge. So like a Zigbee world lives over here, and this device mirrors those devices into the Matter universe. That's kind of what the role of a bridge is. Does 17.9 get close? No. I bet it's the bytes are swapped. Zero A, A B, A A, 3E. Let's just do a quick test. Let's hack it. No, that didn't work either. Well, that's not the problem. Like, they say they use the same standard, but they don't. And it's giving me an integer, which is suspect. That's just the print. Does it work if I don't print it out? Maybe am I printing? Math is not defined. Okay. Does math have is close? Did it just make that up? False. Okay, so the printing agrees with me. Huh. This number is equal to this. This must be like the repr. That's kind of weird. I mean, we probably do want floats to work. Huh. Yeah, I don't know. It doesn't seem to be... I kind of wonder what... print struct pack. Actually, I don't need to do it here. I can do it. Yeah, our zero encoding is right. Import struct struct.pack f ABAAAA angle bracket. I wonder if this example's wrong. I wonder if it's wrong in the ABAA 3E. Oh, you know what? I'm just not decoding it right. I haven't implemented it. TLV float value offset is length offset value length it could just be a bug. Value offset 1 4 value length I will figure this out. Number member, unpack number, offset. Oh, int size, that would do it. What do you think? think the encoded format is. Yeah, the data's right. Yeah, it's unpacking it as an integer. We need to handle non-integers. If self integer true if format -1 is in int size. No, we don't want to uppercase it. We want to take it as is. So this is handling so that's right. Is close. Failed, even though it was 17.899999 to 17.9. Is close is too strict. Oh, sorry. Yeah. I test things, or I work like I have my whole screen. It's a lot closer. My is close is just too strict. Although, could I compare the encoded versions? Because it should be identical, right? Shouldn't it be identical? Are they? Huh. I guess they're not identical. Maybe floats are. Oh yeah, maybe the 1.3 is a double. Python float literal. Python float literal. Floating point. The actual stored value is the nearest representable binary fraction. It doesn't say what floating point representation it uses. Single or double? Implemented using double. Wow, I thought float and typed. Booleans or subtypes. Floating point numbers are usually implemented using double in C. It is narrower than floating point, which is narrower than complex. So it's probably a double. Which is fine. All right, I'm way over time. I'll get it sorted out. This isn't great. We found the bug. The bug was like, we just weren't parsing it as a float. Although, let me just take a quick peek. Encoding. Oh, I guess it does say that it's just 4 or 8 octets, and we know up front. The sender is free to choose either precision at their discretion. So we might need a, yeah, I don't know. We might need a different, instead of using the number, make it an integer class and then have a float one that detects which of the two it needs. I need to check the sender's length. Yeah, I'm gonna wrap up and then maybe I'll do it before I leave. Okay, thank you everybody for hanging out here. Hopefully this was exciting. Hopefully descriptors make more sense to you. They're a really neat trick, but they do have lots of gotchas. Python descriptors, that is. If you want to support me, you can do it by going to adafruit.com and purchasing hardware from Adafruit. Just be warned that they are not shipping potentially soon because they're moving all the stuff. You can purchase from digikey.com or any of the other Adafruit resellers, and that does benefit Adafruit too. If you want to join the Discord server, which is the middle chat here, it's the URL is adafru.it/discord. And thanks everybody for hanging out. I think that I should be streaming next week. I think. So plan on that. Generally, I'm around this month, and I'll probably be working on hopefully the higher levels. Maybe getting the cryptography done. Like the next step once we're parsing packets is to actually do the cryptographic negotiation. So. We'll do that then, and then it's going to be once we have decrypted messages, then we are back in packet land. So we'll see. So yeah, if you want to support me, adafruit.com or any of the other resellers, Discord, I said the URL. Preemptive thanks to DCD for taking timecodes, and also an always thank you to Foamy Guy for filling in on weeks that I can't do, like last week. So thanks to Foamy, I think it was last week. Thanks again, everybody. Have a great weekend. I will chat with you on Discord next week and see you hopefully for the stream next week. I just thought of, like, there is a deep divers role on Discord if you do want to get notified about changes. I barely ever use it, but that's what it's there for. All right, let's go to the window camera. It's a beautiful day here in Seattle. And this is a reflection up there somewhere. Right there, there's my hand. But besides that, it's it. Have a great weekend, everybody. We'll see you next week.